Hi folks, welcome to CppClub screencast. The date is 25th of July 2019. C++20 is feature complete. This is the week after the Köln C++ Standards Committee meeting. And I saw a tweet by the UG chair which said, "No!" And I was wondering if that was about contracts being removed from C++20. There are Köln trip reports by Herb Sutter. He says the C++20 Eagle has wings. He describes what happened. He says, thank you to all of the hundreds of people who participate in ISO C++ in person and electronically. There were more than 200 people in the meeting. The main news are C++20 is feature complete and committee draft ships. The main proposals, according to Herb Sutter, are STD format for text formatting by Viktor Zverovich, a long overdue text formatting facility, a modern one, not the STD.io or IOStreams. Applying spaceship comparisons throughout the standard library, stop token and joining thread, constexpr invoke, constexpr std vector and constexpr std string. Contracts moved from draft C++20 to a new study group. Herb says, at this meeting it became clear that we were not quite done designing the contracts feature in time for C++20. Back when we adopted the feature 1 year ago, we thought it was baked and ready for the standard, but since then we have discovered lingering design disagreements and concerns that we could not resolve sufficiently to get consensus. So that is currently aimed, I hope, for 23, and there's a new study group for contracts, SG21, with John Spice as the chair. Then Herb says that the shape of C++20 is, we know the final feature set, and we can say that this is C++ largest release since C++11. The major features include modules, coroutines, concepts including in the standard library via ranges, spaceship included in the standard library, broad use of normal C++ for direct compile time programming without resorting to template metaprogramming, that's constexpr, ranges, calendars and time zones, text formatting, span, and lots more. This is, he says, the biggest 9-year cycle alongside the previous two, C++98 and C++11. Quite a large amount of stuff to absorb. He makes an obligatory pun on the keywords, concepts, coroutines, constexpr, consteval functions. Now that we know that keywords are not the worst idea, and the paper about renaming them, removing the prefixes and including the async postfix to function declarations is not the best idea, and it was rejected by the committee. So we are now stuck with keywords, and that's okay. He also mentions briefly other progress and decisions, including generation and meta classes and lightweight exception handling. So 220 experts attended this meeting. Now if you go back to Reddit, Bryce Lelbach posted a big update, a trip report. As usual, his very extensive account of what happened, and at the first place is contracts moved out of C++20, so clearly this is a significant decision. It would have been great to have them, but there are various accounts of why they were removed. No consensus seems to be the consensus. Yeah. So regarding contracts, Bryce says, we made the decision this week to move contracts out of C++20. And why was that? So he says, we made major design changes to contracts very late in the C++20 process, including at this meeting. And there's a link to many recent papers about that. We were not confident on the impact of or implications of these changes. We have insufficient implementation and usage experience with contracts. We have concerns that the changes artificially limited future directions. And a unanimous decision was to postpone contracts and remove them from C++20. There's a lot to process in this post. I encourage you to at least browse through it and skim Bryce's notes. It's quite a lot of updates, and the number of comments this thread received is quite large. As for the plan and release schedule, we just had Köln, which resulted in complete CD, that's committee draft wording, and start committee draft balloting, beta testing. The next will be a 2019 meeting in Belfast at the end of the year. And in 2020 spring in Prague, C++20 will be complete. In 1 year, there will be a meeting in Varna, in Bulgaria, and that will be the first meeting of C++23. But it's fair to expect that parts of C++23 targeted papers will be discussed in all the following meetings. There's a table on the status of major C++ feature development, and the changes since last meeting are emphasized, and the changes are executors have now a new compromise design which is approved for C++23, so the current target is 23 and the conservative estimate is C++26. Contracts move to study group, and again current target is 23, conservative 26. Other stuff going into 23 or in the worst case 26 are networking, which depends on executors, reflection and pattern matching. Let me go back to the slides and highlight a few things from this thread. As for the coroutines explanation, this is a reply to a post about the new proposed keywords, which, as we know now, were rejected. But I was initially, I quite liked the proposal to get rid of the prefixes. But this reply changed my mind. The poster says, it'll be much less necessary to know whether you are inside a coroutine than outside of one than most people think. You need to think about reference lifetimes, sure, but that's always true when you see a signature of a function that returns an async object and takes a reference. Though not even close to all coroutine types will be asynchronous. So the signature already tells you a lot. Other than that, the only cases where it's important to track coroutininess, if that's a word, of a function will be in case of asynchronous coroutines, which again won't be all of them. When you hold a resource that has a thread identity when suspending, but since suspensions happen in co-await expressions, these kind of problems will need the local knowledge of suspension points anyway. So an async annotation doesn't help there. And it's completely ridiculous on a 100% synchronous coroutine. And secondly, whether a function is a coroutine or not does not change its interface. You use it like any other function that would return an object of its return type. A function returning, say, a future is completely indistinguishable for the outside world from a coroutine that returns a future. So this kind of turned my mind, and it makes sense. And now I'm okay with the keywords we've got, and I don't think anymore that you need to see if a function is a coroutine by looking at its signature. The other highlight in the thread was about adopting STD WebView. And this is madness. I don't think this belongs to C++ standard. I mean, really? Do we want to have a web browser as part of the C++ standard, complete with the JavaScript interpreter? It's just, how is that going to work? Not only that, but people say in this thread that it is a way for C++ to have a modern UI, which is terrible. You've all seen web application UIs. They are slow, they consume lots of memory, and they look bad on all platforms. Look at things like, I don't know, Slack, for example. It gobbles up memory like there's no tomorrow. Not only that, but generally web application UIs are not accessible. So I hope this doesn't fly, really. Just no. I remember when I first saw STD WebView proposal, I thought it was a joke, and I checked the date, and it wasn't April 1st. The third one was constinit, and it's a brief note which explains what constinit is. You can't modify constexpa variables, but you can modify constinit variables. Effectively, constexpa is constinit plus const. And the fourth one was on the spaceship operator. A quick note from Fu Nathan, who says, you never want to use the operator itself. For regular comparison, you use less than, as before, and others. But it will magically forward to the spaceship operator. If you want a three-way comparison, you can call std-compare three-way, which works on types that don't have the spaceship operator. And you should only use the spaceship operator to write comparisons for your class. And as we know now, for efficiency purposes, you should also write the equals operator. Slide number 4 of 8 this time. STD format is in C++20. There's a blog post by the author of STD format, Viktor Zverovich, and we can see here in on a C++ map that this is the place where format lives. So he announces a text formatting proposal made it into C++20 committee draft. He presents a brief history of the proposal, aka what took you so long. The first proposal idea was posted on Reddit in 2016, in August 2016. There are he says, contrary to the usual design by committee narrative, the standardization process was tremendously beneficial both for the proposal and the FMT library, resulting in numerous improvements. And here are just a few examples, and then he goes through all the examples. And if you, well, for most of us, it'd be a while before we can use the C++20 standard. But in the meantime, we can all use a modern formatting library, which is an implementation of this, and more, and which is called the FMT library, and it has its own cool URL, fmt.dev. It's a very well documented library. It has a friendly license BSD2 clause. It's cross-platform, and it can be used either as a compile library or as a header-only library. It's really fast. There are benchmarks. There's a list of projects using this library. Links to documentation. Keep in mind that this library has more features than what will be in C++20. So if you use it, you might have some problems migrating to the standard C++ later. While we are waiting, this is slide number 5 of 8. While we're waiting for contracts to become available in C++23, there are some ways of emulating contracts. This library is called Contract. It's for C++11. It's a header-only library, boost license. You include the file, and then you use this contract block in your function where you define precondition and postcondition. There's some documentation. You can also define invariants. This is how you define function contract. It's a block that starts with the word contract and then parenthesis function. It should be defined inside a free function using the syntax described. There's a precondition. It looks like a function call. Invariant, postcondition. There can be member function contract, a constructor contract, and destructor contract. There's also a class invariant contract and others. Yeah. So it requires Python 2.6 or later, and it uses a WAF build system, which is a bit non-standard these days, and WAF requires Python 2.6 or later. It compiles with GCC 4.8 or later, or Clang 3.3 or later. No word on MSVC though, so it might not be Windows friendly. The other one is by Felix Petriconi, and it's called Contract Lite. This one is a lightweight C++ designed by Contract Library. It uses CMake, which is standard these days. It seems to use macros, I think. Also has preconditions, postconditions, and invariants. And it also has a way to set handlers for failed preconditions, postconditions, and invariants, which I don't think the previous library had. It seems to be compatible with Visual Studio and Clang. The next one is Boost Contract, which appeared in Boost 167 and newer. There are links to documentation and the location of the code on GitHub. This is probably the most extensive contract library. It requires C++ 11. I'm just looking at how this all looks. You decide on preconditions and postconditions, and then the syntax is inside the function you use. You save the old value of the supplied arguments, and then you check various preconditions, postconditions. Yeah, it's kind of noisy, I should say. I suspect that migrating from this to the standard contracts whenever they are available won't be particularly easy. Slide number 6 of 8. Why STD expected is not in the standard yet. I think it was going to be in the standard, but the library evolution group ran out of time discussing other proposals, and so it didn't make it. I think this is pretty much a guarantee that it will make it into 23, but in the meantime you can use several other possibilities. STD expected is Cybrand's implementation of the STD expected proposal with functional style extensions, and I don't think extensions are going to be in the standard library. Maybe they will be by the time we have 23, but they are in this implementation, and it's really nice and convenient to use. You can use chained calls to and then you can map and do calls in a fluent manner. It supports multiple compilers, both Linux and Windows. Requires catch for testing. Is well documented, and I think it's public domain. Judging by the... yeah, it's public domain. You are free to use it in whichever way you want. The other one is a very nice boost outcome library, and it can also be used without boost if you don't want to bring the boost dependency into your project. It has all kinds of extensions, including functional, like it supports standard error codes. I think there's an example of how to use it with ASIO networking TS. There's an extensive documentation, and it's available in Boost starting with 170. The last one in the list is Leaf, which is an abbreviation for Lightweight Error Augmentation Framework. It's C++ 11 header-only library. It has no dynamic memory allocations. It provides efficient delivery of arbitrary error objects to the correct error handling scope. It supports multi-threaded programming, and it can be used with or without exception handling. It's distributed under the Boost license, and it's also well documented. And when you use it, there's a series of matches. When you call, you wrap your calls in try handle all, and then you provide matcher lambdas to distinguish between certain error codes. So it's kind of mimicking a try-catch idiom. Seems like it's also pretty noisy in the sense that it's not noisy, intrusive. It requires you to structure your function in a certain way to be conformant with this library. Slide number 7 of 8. Microsoft to explore using Rust. It's not actually C++ specific, but we do mention Rust now and then as another systems language, and I watch its progress. And apparently Microsoft is to explore Rust as an alternative to C++, and as a way to improve the security posture of its and everyone else's apps. In a new blog series, we will highlight Microsoft's exploration of safer system programming languages, starting with Rust. The end game is to find a way to move developers from the aging C and C++ programming language, oh boy, to so-called memory-safe languages. Well, right, to that I have this picture I found on the internet, which shows a Simpsons character which says, "Is my code bad?" And then, "No, it's the language that is wrong." The last slide, number 8, is a screenshot of the thread we looked at in the beginning. This was a thread by Bryce Lelbach about the Köln meeting, and towards the bottom someone posted that metaprogramming is destroying C++, to which Vittorio Romeo brilliantly replied in italics, "Laughs in const expo." And for that he deservedly received Reddit Gold. So that's it for today. Talk to you later. Bye.